Vector components. Okay, let's do some review from last year and the last lesson. So let's say you're going 5 meters east and then you turn and you go 8 meters north. Okay, so when you're doing these vector problems, addition, subtraction, whatever it happens to be, always put your little rose compass so you know what direction is what. So just put that little thing, mark north, and you can put east on there if you want. And now whenever you make a drawing, you'll know, or I'll know what direction you're going. Okay, so 5 meters east is going to look something like this. You should have a scale, but it doesn't really matter because you're doing this on blank paper or a test. And now mark what it is, 5.0 meters, and in those square brackets you put the direction. And since we have a magnitude and a direction, this thing is a vector. If we just had the distance, it would be a scalar. Okay, so then we turn and we go 8 meters north. So it looks something like that. Again, mark it 8.0 meters, and you're going north. Distance, direction, it's a vector. Now this is displacement. Okay, so you want to figure out what is the resultant. Well, you're starting here, you're going along here, and you end there. So draw in a big fat double arrow with a nice filled in tip. So this is the resultant vector. Okay, so when they look like this, it's a basic right triangle, and you can use Pythagorean theorem to solve it. How do we do that? Well, first we want to get the distance that we travel. Okay, to do that, again, like I said, this is a right triangle. Okay, and so what does that mean? A squared equals b squared plus c squared, or c squared equals a squared plus b squared, it doesn't matter. In this case, r squared, the hypotenuse, equals 5.0 meters squared plus 8.0 meters squared. Okay, we're just talking about the distance, so you don't have to put in the direction. You don't have to worry about that yet. So to solve that, take the square root of each side, which is going to give you r equals the square root of 5.0 meters squared plus 8.0 meters squared. Okay, so 5 squared is 25, 8 squared is 64, 25 plus 64 is 89, so r equals square root of 89. So use your calculator, look at that, I have one here. Let's figure out what square root of 89 is, and you get 9.43. Oh, this is a good significant digit question. There's 2 in the 5 meters, there's 2 in the 8 meters, so we're going to round this off to 2. So r equals 9.4 meters. So there's your distance. Now we want to know direction, okay, which is an angle right there. This is theta. I don't know why I'm drawing it in fat, but anyway. To get your angle, you're going to need to remember SOHCAHTOA. Sine, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. Okay, if this is my angle, this one over here, remember this is opposite. I forgot the T. This one down here, this guy is adjacent, and this one is the hypotenuse. So, theta, we have a value for opposite, we have a value for adjacent, we just found the one for hypotenuse. So you could actually go ahead and solve this with either sine, cos, or tan. But it's always best to just use the values that you're given. Okay, so in this case we want to use 8 and 5. That's O and A. So if you remember, that means that tan theta equals opposite over adjacent, okay, which is 8.0 over 5.0. Now, how do you solve for the angle? I don't want to know what tan of the angle is, I want the angle. Well, remember that if you have tan theta, theta equals tan inverse of 8 over 5. So we can get our calculator again, and we'll do tan inverse of 8 over 5. So that's this button here, tan inverse 8 divided by 5. Remember to close that bracket if you're using this TI-83. Enter 58 degrees. While I'm at it, remember, you check in mode right here. If you go down to, it can either be in radians or degrees. Okay, when you're in physics 12, do everything in degrees. That's what I already had it set it at. But if you get some weird value, if you tried it in radians, it would give you like 1.0 something. That would be wrong. It is clearly not 1 degree. Obviously this picture isn't to scale, but there's no way that's 1 degree. 58 makes a lot more sense. So now we just have to write the answer. So the total displacement, okay, displacement means it's a vector. Anytime you're doing a vector, you put the arrow on top. R equals, now we want our distance, which we have 9.4 meters. And we want to state the direction. So we're going 58 degrees. Well, 58 degrees is from here, moving up that way, 58 degrees. So if you look at this and our little compass that we conveniently drew in before, this is 58 degrees north of east. We're heading north of east. So we can write that in as 58 degrees north of east. Okay. Let's talk about those direction things as a bit of review from last year. Again, I'll put in, this is my north. Okay, so what is south of east? What does that look like? South of east. Well, east we know looks like that. Okay. And then we know that south of east means we're going this way of east. Right? We're going down from east, south of east. So your vector would be something like that. Okay? What would north of east looks like? North of east is up of east. You're going in this direction, so your vector would be something like that. And you can have any combination of these. Okay? Let's say we started off going north. Here I am just going straight up north. What if I went west of north? West of north. So west is over here. That means I'm going this way, west of north. And you can draw it in like that. Now, this right here would be directly west. Okay? So, west of north, you could also state it, that same angle could be stated as north of west in this yellow arrow here that hopefully turns out. North of west. So if we had some angle, let's say we went 30 degrees this way. Let's say we went 30 degrees west of north. Okay. You could also state that as some angle north of west. Okay, so the angle between north and west is 90 degrees. You know, it's 90 degrees between all of these guys in here, right? So 90 degrees, I've already gone 30. That means this angle in here, you should figure out, is 60 degrees. Okay, so that means that 60 degrees north of west is the same angle as 30 degrees west of north. So it's up to you how you state it. Just make sure that you state it correctly when you answer it. It has to be the right way. Don't figure out this angle and then tell it to me north of west, because it's going to be wrong. Okay, so just keep track of which way you're going. Like south of east, north of east, west of north, north of west. Let's do one final one just for fun. This is west. What would south of west look like? Okay, south, you're going down from west. South of west looks something like that. Okay, so you're going to need to remember that for your directions. Now let's move on. We're going to add some vectors, and you're going to need to break these up into components to do it. Okay, so your first lesson was just right angle triangles. Pretty easy. We reviewed that. So Johnny, he walks 5 meters east, he turns, and then walks 8 meters 40 degrees south of east. South of east. What is Johnny's displacement? Okay, so first thing, every time we're going to draw it. Put in your little compass there. Up is north. It's also really good practice to always say that north up is positive and right east is also positive. And that way, whenever you're adding south angles, it's like saying negative north. Or whenever you're adding west angles, it's like adding negative east. So go up positive, go right positive. Go left negative, go down negative. So we walk 5 meters east. 5 meters east looks something like that. Label it. It's a vector, distance, direction. Turn and walk 8 meters 40 degrees south of east. Okay. If you can't picture immediately what that's going to be, it might make it easier for you to just draw in your compass here. Okay, so we've gone this way, now we're going to start here. So I've just drawn this cross the same as this one. So we're going to go 40 degrees south of east. Okay, south of east. We want to go down from east. So 40 degrees south of east means it's going to look something like this. Okay, we went 40 degrees south of east. So, what does your resultant vector look like in this case? We started here, we went this way, then we went this way. We're going to end up down there. Draw a big double arrow with a big fat tip. Okay, so this is going to be your resultant. And I should have also labeled this as 8 meters 40 degrees south of east. Okay, so how do we figure this one out? It's not a right triangle. It's not a right triangle. So the easiest way is to figure out each of the components for your vectors. I like to do that off to the side first. So we're going to figure out for the 5 meter east vector, we're going to draw it over here and we're going to figure out what's the x component and what's the y component. Okay? So the x component, that means you're going in this direction, right? Well, what is the x component if you're going in this direction? It's 5 meters, right? We go 5 meters in the x direction. Now, for this vector, how much do you move in the y direction? You don't move any, right? You're not going up or down, you're just going right. So in your y direction, you got 0 meters. So those ones are beauties, because you only have one thing to worry about. However, on your next vector, you are definitely going to have 2. So 8 meters, 40 degrees south of east. We want to find out the x component, and we want to find out the y component. Okay, so to highlight this, I'm going to draw in this red vector right here on its own down here as an aside. Okay, that's pretty much the same. So you want to figure out the x component. The x component is the amount that goes this way, right? And the y component is the amount that goes this way. Just like on that first example, if I went this way, and then I went this way, and I added them together, my resultant would be this one. Well, I already have the resultant. I want to break it up into its components. One in the x direction, one in the y direction. I go this way first, right. I go this way next, down. I go east and then south. So, we know that this angle here is 40 degrees. We also know that this is 8.0 meters. So we want to figure out Rx and Ry. You're going to need, again, SOHCAHTOA. So if you remember, sine theta equals opposite over hypotenuse. This is theta right here. I can draw that in. There's theta. Opposite Ry, hypotenuse, is 8. And we already know the angle is 40 degrees. So we can actually write that out. Theta is 40 degrees. Opposite is Ry. That's what we're solving for. And the hypotenuse is 8 meters. So if you rearrange this equation, multiply each side by 8, then you're going to get 8.0 times sine 40 degrees equals Ry. So if you bring your calculator, oh, this thing takes forever to turn on. So while it's turning on, I'll put it over to the side, and we'll start on the next one. Okay, Rx. Rx, we're going to have to use either cos or tan. I imagine you can guess that it's cos, because we don't have these two values. Remember that cos theta equals adjacent over hypotenuse. We have theta. Adjacent to theta is Rx. The hypotenuse is 8. So that means cos 40 degrees equals Rx over 8 meters. And if you rearrange that one, 8 times cos 40 degrees equals Rx. So by using simple trig, we can figure out what the components are. Okay, so this thing's on. It's in degrees. Again, make sure that it is. And let's figure out what these are. So 8 sine 40. 8 times sine of 40. Remember to close your brackets. We get 5.14. We only have two significant digits here with the distance. So we're just going to use two significant digits here in the final answer. I would carry them through until you're completely finished. So let's just type in 5.14 meters for Ry. Ry equals 5.14 meters. Now Rx, let's get it. Let's plug that into the calculator. 8 times cos 40 degrees, 6.128. So let's put in 6.13 for now. Okay, so this one up here is 5.14 meters, and this one down here is 6.13 meters. And if you were to add those up, you'd get this 8 meter right here. So now we know our components for the first one in the x direction and the y direction, and our components for the next one in the x direction and the y direction. So see how I've got this Rx here? That Rx can be drawn in right there. It's the same thing. Okay? And if I erase my labeling, you could also draw in your Ry right there. And what do you notice is this makes one big right triangle. And we can use that one big right triangle to solve for our resultant. So let's redraw it using what we know. So in the x direction, we go 5 meters east, and we also go 6.13 meters east. I totally labeled these wrong. Who caught that? This is 6.13 meters, 5.14 meters. So we go 5 meters, and then we add 6.13 meters, which gives you 11.13 meters in the x direction. In the y direction, remember we go 0 meters, but then we add 5.14 meters, which gives you 5.14 meters. So you can draw this now as one big triangle. This is 11.13 meters in the east direction, followed by 5.14 meters south. And you get that same big fat resultant vector as up here. Okay, so this triangle is this triangle. And now you can use your basic trig with tan to figure out what the displacement is. So, putting my calculator to the side so it doesn't turn off again. 11 meters, 5 meters. How do we get r? You know, it's just r squared equals x squared plus y squared, or c squared equals a squared plus b squared. So r squared equals 11.13 meters squared plus 5.14 meters squared. And so if you take the square root of each side, that means that r equals the square root of these two squared. Again, break out your calculator and figure out what that is. So 11.13 squared is 123.8 plus 5.14 squared is 150.29. So r equals the square root of 150.29 meters squared. What's the square root of 150.29? 12.26. 12.26. So r equals 12.26 meters. Okay? And that seems about right. Okay, so now you've got the distance, and now we want to know the angle. And that angle is theta. So originally this thing looked pretty complicated, but if you break it up into the components, all we're left with is a simple right triangle, and the right triangle you already know how to get all these, right? Because tan theta equals opposite over adjacent, and we know opposite and adjacent, so we can get the angle. So theta equals tan inverse of opposite, which is 5.14, divided by adjacent, which is 11.13. And again, we'll use a trusty calculator. So let's do tan inverse of 5.14 divided by 11.13, and you get 24.78 degrees. Okay, so I wanted you to carry through the digits to the end so that you would get an accurate angle here. Okay. However, remember, whenever you're giving an answer, check your significant digits. We were given 5 meters east, 8 meters south of east, and we were given our degree. All of them have 2 significant digits. So when we state the final displacement, r equals, we're going to use 2 digits here, okay, so it's 12 meters. And then when we're going to give our angle, we're going to do 25 degrees. Now, what direction are we going? Okay, what is this angle? This angle is down from this way, south of east. 25 degrees south of east. R equals 12 meters, 25 degrees south of east, and that is the final answer. Break each vector into its components, make a big triangle, and then find your solution. Okay. Now, that's nice and pretty because it was easy to see what the big triangle was going to be. They might be nasty and give you one where it's a little bit more complicated, but the process is going to be the same. You're going to break it into components first, then you're going to redraw a triangle, then you're going to find your solution. So let's say I drive 20 meters north and I make a sharp turn and head 40 meters, 20 degrees east of south. So first of all, we want to draw it. That's north, put this in first. So I drive 20 meters north. That's easy to draw right here. 20 meters north. Then I make a sharp turn and head 40 meters, 20 degrees east of south. 20 degrees east of south. What does east of south look like? Okay, remember, this is east. This is south. East of south means I'm going this way. East of south. And that's 20 degrees in there. Right? So it looks something along those lines like that. Which is going to be like this. This angle in here, 20 degrees. This vector right here is 40 meters. 20 degrees east of south. So what's our resultant? Let's draw it in green. I start here, I go up here, I turn sharply, I come back down here. I'm going this way. Here's my resultant. Draw it in with a big fat arrow. Tail to tip. This is my resultant. Okay, notice this triangle isn't the same as the last one. Okay? But we can still follow the same steps. So, same steps. The first one is we want to take our 20 meter vector, this guy right here, and break it into components. Okay, our 20 meter vector. Now let's do that. In the x direction. In the x direction, we have no movement, 0 meters. In the y direction, we're going 20 meters up. So that's positive 20 meters. Remember, up is positive, right is positive, left is negative, down is negative. Okay, so that one's easy. Next one, we're going to break it into components. If you look at it, let me draw it for you again on its own. It looks like this. It goes down. This angle right here is 20 degrees. Okay, we want to get an x direction, or an x component, and a y component. We also know that this is 40 meters. We're going to do the same thing that we did in the last question. Except this right here is 20 degrees. Okay, so first of all, in our triangle, we want to figure out what theta is. We need to have theta to figure out our values. Okay, well, this right here is the south direction. This right here is east. between south and east, that's a right triangle, so this is 90 degrees between this one and that one. So 90 minus 20 leaves us with 70. So we know that theta in this triangle that we're drawing is 70 degrees. Okay? So, sine theta equals opposite over hypotenuse. In this case, here's theta, opposite is ry. Hypotenuse is 40 meters. Okay? If you rearrange that, and we know theta is 70 degrees, then you get ry equals 40 times sine 70 degrees. And I gotta wait for this calculator to turn on again. While it's doing that, oh, I got it. So ry equals 40 times sine 70 degrees. 40 times sine 70 degrees. 37.59. Okay? So ry equals 37.59 meters. Alright. Cos theta equals, I have no idea, adjacent over hypotenuse. Okay, adjacent is Rx over hypotenuse, which is 40. And again, theta is 70 degrees. So we can rearrange that to write Rx equals 40 times cos of 70 degrees. And again, we can use our calculator to figure out what that is. 40 times cos 70 degrees, 13.68. So we get 13.68 meters. Okay? So this one right here is 13.68. This one right here is 37.59. So, we want to add our components of the vectors together to draw a new triangle. Now, to do that, we're going to have to keep in mind what direction we're going. Okay? So when we do that, remember we said up is positive. Let's check this. And right is positive. This is 0, we don't have to worry about it. Ry, 20 meters. Where are we going? Up. Okay, so that's positive. So this one's fine. But down here, let's take a look. Rx is going right. What's right? It's positive. Okay, so it's 13.68, fine. Ry, what way are we going? Down. We're going down. That's negative. Okay, so that means Ry is negative 37.59 meters. That should make sense to you. Look, first we went up this way, then we came around and came back down this way, right? This component is going in the opposite direction than this component is going. This one's going up, this one is coming back down. That's how we end up over here. So, when we add them together, you have to take that into account. So let's figure out Rx. Well, we got 0 meters. And then what are we going to add? We're going to add 13.68. And obviously that gives us 13.68 meters in the x direction. Ry, we've got 20 meters. And then we're going to add negative 37.59 meters. So 20 minus 37.59 is negative 17.59. Okay. How do we draw that triangle? In the x direction, we're going 13.68 meters. Okay? Let's do this in its own new slide. In the x direction, we're going 13.68 meters. In the y direction, we're going negative 17.59 meters. What's the resultant from all of this? We start here. We end down here. This is our resultant vector. This is our resultant. Here's the angle. Now you have a simple triangle and we can figure everything out. Note that this right here, okay, this is negative 17.59, this is 13.68. If you look at this resultant vector, it's the original resultant vector that we drew right here, because we went negative 17 and then positive 13. Okay, I just drew it a different way, but you can see it's the same one. If I went negative 17 and then positive 13.68, that's what you would get. Okay, so now let's use these values and figure this out. R equals the square root of 13.68 squared plus negative 17.59 squared. Got away from my calculator while I'm doing that. Theta equals tan inverse of opposite over adjacent. That's 17.59 divided by 13.68. Come on, baby. There it is. Alright, 13.68 squared plus 17.59 squared. I just ignored the negative because I know that negative times negative is positive. That gives me 496. The square root of that answer, the square root of that answer gives us 22.28. Okay, so 22.28 meters is the distance, and the angle is tan inverse of 17.59 divided by 13.68, 52.12 degrees. Okay, so you have the distance, you have the direction. 52.12 degrees. What is that direction? We're going this way from here. We're going south of east. You should make yourself familiar with all of those because you're going to need them. So when we finally state what our resultant vector is, we're also going to worry about significant digits. In the question 2, 2, 2, we're going to use 2 again. So this is going to be 22 meters, 52 degrees, south of east. Okay, so it's the same thing every time. Break it up into components. Break it up into components. Draw a new triangle. Okay, either on its own, or if you can really see it, then you can draw it right here. If you can't, draw a new one. Okay,